Earth is often treated as familiar, because it is the ground beneath us and the sky above us. But from a cosmic point of view, it is extraordinary. It is the third planet from the Sun, one of the rocky inner worlds, and the only astronomical object currently known to harbor life. That does not mean life exists nowhere else. It means that, so far, Earth is the one confirmed example of a planet where chemistry became biology, where oceans, air, rock, sunlight, and time combined into a living world. To understand Earth is to understand a rare balance, close enough to the Sun to receive useful energy, protected enough to preserve its surface, active enough to recycle materials, and wet enough for life to flourish. The most important thing about Earth, when seen from space, is not the land. It is the water. Earth is an ocean world, and nearly all of its water is contained in one connected global ocean. This ocean covers about 70.8% of Earth's crust, leaving only 29.2% as land. That ratio shapes almost everything: climate, weather, biology, and even how heat moves around the planet. Liquid surface water is especially important because it acts as a solvent, a transporter, and a stabilizer. It allows chemicals to mix, nutrients to circulate, and temperatures to change more slowly than they would on a dry world. Earth is not just a rocky planet with some water on it. It is a water-covered planet with islands of land rising above a global sea. The land that does rise above the ocean is not distributed evenly. Much of it is concentrated in continental landmasses, and many regions are at least somewhat humid and covered by vegetation. This matters because land and life interact constantly. Plants draw water from soil, release vapor into the air, help form clouds, and influence the movement of carbon. At the same time, deserts, forests, grasslands, mountains, and coasts create many different habitats. But Earth's water is not only found in oceans and rivers. Huge ice sheets in the polar deserts store more water than all groundwater, lakes, rivers, and atmospheric water combined. These frozen reservoirs are part of the planet's long-term water balance, locking away enormous quantities of fresh water while also reflecting sunlight back into space. Earth's surface is not fixed. Its crust is broken into slowly moving tectonic plates, and those plates shape the planet over millions of years. Where plates collide, mountains can rise. Where they pull apart, new crust can form. Where one plate sinks beneath another, volcanoes and deep ocean trenches can appear. Earthquakes are also part of this same moving system. Though destructive on human timescales, plate tectonics plays a major role in making Earth habitable over geological time. It helps recycle carbon between the atmosphere, oceans, rocks, and deep interior. It builds continents, refreshes landscapes, and creates chemical pathways that influence climate. Earth's solid surface behaves less like a dead shell and more like a slow, planetary engine. Deep below the crust, Earth has another crucial feature: a liquid outer core. This moving, electrically conducting layer helps generate Earth's magnetosphere, an invisible magnetic shield surrounding the planet. The Sun constantly releases streams of charged particles called solar wind, and space also contains high-energy cosmic radiation. Without protection, these particles can erode atmospheres and damage living cells. Earth's magnetic field deflects much of this harmful radiation before it reaches the surface. It does not make the planet invulnerable, but it creates a protective boundary that has helped Earth preserve a stable environment across immense spans of time. The auroras near the poles are a visible clue to this invisible defense, showing charged particles interacting with the upper atmosphere. Earth's atmosphere is another layer of protection and stability. It is composed mostly of nitrogen and oxygen, with smaller amounts of other gases, including water vapor and carbon dioxide. The atmosphere shields the surface from many meteoroids, which burn up as they enter at high speed. It also blocks much of the sun's harmful ultraviolet light. But the atmosphere is not only a shield. It is an active, dynamic system that moves heat, moisture, and gases around the globe. Water vapor forms clouds that often cover large portions of the planet, while winds transport energy between regions. The air above us is not empty space. It is a constantly shifting planetary system that helps define what Earth's surface can be. One of the atmosphere's most important effects is the greenhouse effect. Sunlight reaches Earth, warms the surface, and some of that energy is emitted back as heat. Greenhouse gases, especially water vapor and carbon dioxide, capture part of that outgoing heat and keep the surface warmer than it would otherwise be. This natural process is essential. Without it, Earth would likely be too cold for widespread liquid water. With it, the planet maintains an average surface temperature of about 14.76 degrees Celsius, or 58.57 degrees Fahrenheit. That is warm enough for liquid water under normal atmospheric pressure. The key is balance. A certain amount of trapped heat makes Earth habitable. Too much extra heat can disrupt the climate system's life depends on. Earth's climate is powered by unequal sunlight. The equatorial regions receive more direct solar energy than the polar regions, and that imbalance drives circulation in both the atmosphere and the oceans. Warm air rises, cooler air sinks, winds form, currents flow, and water evaporates, condenses, and falls as precipitation. This movement creates climate regions, from tropical rainforests to dry deserts to polar ice. It also supports chemical cycles, including the carbon and nitrogen cycles, which are essential for life. Weather is the short-term expression of this system: storms, rainfall, droughts, winds, and changing temperatures. Climate is the longer pattern beneath it. Together, they make Earth a planet of constant exchange, where energy and matter are always on the move. In shape, Earth is not a perfect sphere. It is rounded into an ellipsoid, slightly wider at the equator than from pole to pole, with a circumference of about 40,000 kilometers, or 24,900 miles. It is the densest planet in the solar system, and among the 4 rocky planets, it is the largest and most massive. Earth orbits the Sun at an average distance of about 1 astronomical unit, meaning sunlight takes roughly 8 minutes to reach us. One orbit takes about 365.25 days, which is why calendars need leap years to stay aligned. Earth also rotates once in slightly less than a day, about 23 hours and 56 minutes relative to the stars. Our everyday sense of time is built from these planetary motions. The seasons come from Earth's tilted axis. The planet's rotation axis is not perpendicular to its orbital plane around the Sun. Instead, it leans, so different hemispheres receive more direct sunlight at different times of the year. When the northern hemisphere is tilted toward the Sun, it experiences summer while the southern hemisphere experiences winter. Half an orbit later, the pattern reverses. Seasons are not caused by Earth being much closer to or farther from the Sun. They are caused mainly by the angle and duration of sunlight. This axial tilt gives Earth a yearly rhythm: changing temperatures, growing seasons, animal migrations, snow cover, rainfall patterns, and the timing of ecosystems across the globe. Earth has one permanent natural satellite, the Moon. It orbits at an average distance of about 384,400 kilometers, or 238,855 miles, which is about 1.28 light seconds away. The Moon is roughly a quarter as wide as Earth, making it unusually large compared with its planet. Its gravity causes tides by pulling on Earth's oceans, raising bulges of water that shift as Earth rotates. The Moon also helps stabilize Earth's axial tilt, reducing extreme wobbling over long timescales. Over time, tidal interactions gradually slow Earth's rotation. Meanwhile, Earth's gravity has already locked the Moon's rotation, so the same near side always faces us. The Moon is not just a companion in the sky, it is part of Earth's habitability story. Earth formed about 4.5 billion years ago from gas and dust in the early solar system. During its first billion years, oceans formed and life emerged. Once life appeared, it did not remain a minor detail. It spread across the planet and began altering Earth itself. One of the most important transformations was the Great Oxidation event about 2 billion years ago, when life helped increase oxygen in the atmosphere. That change reshaped chemistry, opened pathways for more complex organisms, and made the modern atmosphere possible. Earth's history is therefore not just geology followed by biology. It is a feedback story, where life changes the planet, and the changing planet reshapes life. Humans emerged in Africa around 300,000 years ago and eventually spread to every continent. Like all species, we depend on Earth's biosphere and natural resources: air, water, food, stable climate patterns, fertile soils, and living ecosystems. But unlike most species, humans now influence the planet at a global scale. Industrial activity, land transformation, resource extraction, and greenhouse gas emissions are changing the climate and placing pressure on the biosphere. The current human impact is considered unsustainable because it threatens both human livelihoods and many other forms of life, contributing to widespread extinctions. Earth remains the only known living world, but its future conditions are not guaranteed. Understanding the planet is not just science, it is a guide to responsibility. If you found this helpful, please like this video and subscribe for more explainers.